Archimedes is draining his bathtub. Every 2 minutes that pass, 7 gallons of water are drained. Which of the following functions can represent the number of gallons of water in the tub W as a function of the minutes that have passed T? So let's think about this visually. So let's plot the number of gallons of water we have. Let's put that in the vertical axis. That is a function of time. As time passes, we will lose water at a fixed rate. So this is our time axis right over here. So we're going to start with some initial volume of water in the tub. And they actually don't tell us what that initial volume of water is, but let's just call that W, capital W sub 0. So this is just the initial volume of water. Initial, we're doing everything in gallons. So let's say the initial number of gallons. Initial number of gallons, or the number of gallons at time equals 0. This is T equals 0 right over here. Then they tell us that every 2 minutes that pass, so this is going to, time is going to be given in minutes. In minutes. Time is in minutes, and the W is in gallons. In gallons. So say every 2 minutes that pass, 7 gallons of water are drained. So let's say 2 minutes pass from time equals 0. So that is 1 minute. So this is 1 minute. And this is 2 minutes right over here. So we have 2 minutes passing. And how much water is going to get drained? Well, they tell us 7 gallons of water are drained. So we're going to, after 2 minutes, we're going to get to W naught minus 7. However much water we had before, we're going to have 7 gallons less. W naught minus 7 is where we go. And so if we were to plot the amount of gallons, or the number of gallons we have as a function of time, it would look something like this. It would look like a line. It would look like a line that goes something like that. So one thing that we could ask ourselves is, what is the rate of change of W with respect to T? What is the rate of change of our vertical axis with respect to our horizontal axis? And that's also known as the slope of our line. Well, the rate of change of our, so we could write that as the rate of change, this delta symbol, this Greek letter, this triangle, is just shorthand for change in. So our change in W for a given change in time. Well, we know that when time increases by 2 minutes, and time is in minutes, W decreases by 7 gallons. Because it decreases, it's going down. And we see that. This is a downward sloping line right over here. And we see it graphically right over here. When our change in time is positive 2, our change in time is equal to positive 2. Our change in volume, so this is this distance, which is the same thing as this distance right over here. Our change in the number of gallons is equal to negative 7. So this right over here is the slope of our line, or the rate of change of the number of gallons with respect to time. Now, we don't know the exact starting position or the exact W-intercept, but we just called it W sub naught. So we could write a general equation here. We could say that the number of gallons is equal to the initial gallons that we have, plus negative 7/2 times time. Or we could just call this minus 7 over 2, that's just the negative 7/2 right over there, times time. And this should make complete sense now. We have our vertical axis intercept, often called the y-intercept, but we're not calling the y-axis, this isn't called the y-axis anymore. We have our vertical intercept, and we also have the slope of our line here. If you're familiar with slope-intercept form, we normally write y is equal to mx plus b, where this is the slope and this is the y-intercept. We've written it the exact same way. We've said W is equal to negative 7/2 t plus W naught. I just swapped these two things around, and notice this is the slope and this is the y-intercept. So which of these match that pattern? Well, let's see. I should start with some positive number of gallons, and I'm subtracting 7/2 t. So the only one that matches this is this one right over here, is 50 minus 7/2 t. Now, even if you didn't think anything about slopes and you were just looking at these choices here, you would say, well, look, I should start with a certain number of gallons of water, and then it should only decrease as the amount of time passes. This one wouldn't satisfy this. At time equals 0, I have no gallons here. Well, that doesn't meet the constraints here. I have a certain number of gallons here. So this doesn't make sense. Here, at time equals 0, I have 100 gallons. But then as time passes, that will only increase. So this is, this is the faucet's on here. It's not being drained, so that doesn't work. Here, once again, I'm starting with a certain number of gallons when time equals 0, and then as time passes, it's increasing my number of gallons. So once again, the faucet is on right over here. So once again, the only one where I'm starting with a certain number of gallons, and then as time passes, my number of gallons are reducing, because this is a negative value, is this choice right over here.